Hello friends, welcome to my channel. Let's have a look at problem 2483, minimum penalty for a shop. In this video, we're going to share a solution based on dynamic programming, or we can see just using partial sums. So first, I'll read through the problem statement to digest the problem requirement. And then we do the analysis and give a walkthrough. And finally, we share the code. First, the problem statement. We are given the customer visit log of a shop represented by a zero-index string called customers, consisting only of characters N and Y. So if the ith character is Y, it means that the customers come at the ith hour, whereas N indicates that no customers come at the ith hour. So below explains what a penalty is. So if the shop closes at the jth hour, right, then the penalty is calculated as follows. So notice that the close hour is in between index 0 up to and including n, where n is the length of the customers. So for every hour when the shop is open and no customer comes, the penalty increases by 1. And for every hour when the shop is closed and customers come, the penalty increases by 1. So we want to return or find the earliest hour at which the shop must be closed to incur a minimum penalty. So here is a note. Note that if a shop closes at jth hour, it means that the shop is closed at hour j and onwards. It will remain the closed status. So here are several examples. So in example 1, so the output is 2. So you can look at the explanation. So we are going to look at the details for this example. So for this second example, so because there's no customers at all, so we just close at the very beginning. So that is hour 0. And example 3, so we have 4 customers, so we'd better to close after all the visits of the customers, that is hour 4. So this 4 is the length, right? So before we do the analysis, let's also look at the constraints. First, the length of the customers is in between 1 and 10 to the power 5. So 10 to the power 5 is a decent large number. Secondly, the customer's string contains only characters Y and M, right? So that's the problem statement and the corresponding extra assumptions. So now let's look at the analysis. So in this problem, we can use partial sums, or we can see DP, so to do the coding. So first, let's assume N is the length of the customers. So actually for convenience, so I'm going to change the function signature or argument name customs to be the capital A. So we will define the following 2 variables, generic elements. So pre-I, so which is the number of n's before index I. So this is the penalty due to no customer before hour I if we close the store at hour I. Again, this I runs from 0 to n, both ends inclusive. So similarly, the suffix I is the number of y's on and after index I. So this is the penalty due to have customers on or after hour I if we close the store at hour I. And then for each closing hour I, so we could compute the penalty by just compute pre-I plus suffix I, right? And then we just need to do the proper return. So that's the idea. So before we write code, we need to explain the DP update rule. So actually, if we realize, so this are the prefix sums and suffix sums for y's and for n's and y's respectively. So the DP update rule is very simple. So pre-I is the number of n's before I. So it equals the number of i's before I minus 1, then plus we check if the I minus 1 character is n or not, right? So similarly, suffix I is the suffix I plus 1. So in other words, the y's after I minus 1, and plus check if the ith character is y or not, right? If it's y, we increment by 1. So because of the way or the format of DP update rule, so we need to do the setup for this pre and sub tables for I increasingly and decreasingly respectively, right? In other words, to set up pre, we need to iterate I from small to large, and to determine suffix I, we need to iterate I from large to small. So here's example 1. So in this example, a equals y and y. So we can see the pre. So before index 0, the number of n's is 0, 0, 0, and 1, and 1, right? So this is the pre. So similarly, you can check the number of y's after or on our I. So for our 0, so the number of y's is 3. So 1, that is 2. So for index 2, that is 1. For index 3, so it's 1, because it includes them in this case. And for our 4, so after our 4, is 0. So the penalty is just the sum of the corresponding positions. So that is 3, 2, 1, 2, 1. So this is the smallest one occurring at our 2. So we return 2. So the minimum penalty is 1. Actually, this penalty occurs if we close at times 2 and 4. But we need to return 2 according to the problem requirement. So with that said, so we are ready to write the code. So first, let me do some preparation. So let's call it step 1, preparation. So first, I'm going to track the length of this customer log. So let's call it n. So we are going to set a pre and a sub list. So notice that the length will be m plus 1 because there are m plus 1 closing hours starting from 0 and ending at n, right? Both ends inclusive. So next, we are going to do DP update or set up the DP tables. So first, I'm going to set for the pre. So for this, I'm going to iterate for I in range 1. I can start from 1 because the 0, so before 0 is just 0, right? So then ending at m plus 1. So in this case, so pre-I will be pre-I minus 1. And then we want to check if the I minus 1 character is n or not, right? So this is for the update for pre. Next, we are going to set for suffix. So for this, I'm going to iterate from the backwards. So for I in range, so let's see, n minus 1, we are going to start from n minus 1. So -1, -1. So in other words, the suffix n will be default to be 0 because after index n, nothing. So in this case, so we're going to do the suffix I, so which is suffix I plus 1. And then we want to check if the character at index I is a yes or no, right? So this way, we finished the setup for the 2 DP tables. So next, so we can actually prepare the return. So for this purpose, let me first introduce a penalty, so which I will set to be very large number, and also I want to introduce a result. I'm going to set it to be a large number too. So here, so I can set this to be, say, float infinity. So if you look at the length, right, so you can set it to be, let's say, 10 to the power 5 penalty, let's see, plus plus 1 or plus 2, plus 2, and then the result I will write as n at the very beginning. And then what we're going to do is iterate for I in range, so from 0 up to n, right? So let's write n plus 1. Then the current penalty will be pre-I plus sub I, right? Then if the current penalty is less than the global penalty up to now, then we're going to set the penalty to be current penalty, and then we set the result to be the current index. So notice that if the current penalty equals the previous global penalty, so we do not reset the result because we want to return the smallest index or earliest hour. So after this value for loop, so we can return the result state. So this actually forms a full solution format for this problem. So now let's do a check. Yeah, this passes the first example. So actually it's good to test example 2 and example 3, because these two are special case. Because all these are ends, so we'd better to just close, right, at the very beginning. So we get 0. And this, so we have a customer all the time, so we just need to close after all customer visits, a visit. So this is going to be 4, right? So with that said, let's look at the generic case. Yeah, it passes all the cases. So here we write the code using the partial sums, or we can see we use dynamic programming. So here the time complexity is for sure O(n), but here we use space complexity is also O(n). Actually, it's very straightforward to reduce the space complexity, so we will not do that effort here. So with that said, I guess that's about it for this problem and this video. Thank you.